This is my attempt to explain to you the difference between weight and mass. First of all, they are related topics, which often confuses students. For example, all things that have mass also have a gravitational attraction to each other, which is weight. So let's start by just defining the two terms, and then we'll go from there. So mass is basically the amount of stuff in an object. So mass is the amount of stuff in an object. Weight is a measurement of how attracted those two objects are to each other. And for example, if you increase the mass, you will increase the gravitational attraction. However, if you take the objects and move them further apart from each other, they won't be as attracted to each other, so you actually decrease the weight, and their mass might stay the same. This can all get incredibly confusing, and so I've tried to come up with a little example going from the moon to the earth to help you understand that. Alright, so weight is a gravitational attraction between two objects, and we actually measure that on a spring scale, and that unit that we use is newtons. So let's come up with an example. Let's hang something from our spring scale here. In class I hung an actual owl, but I'm just going to hang a block here. And that block is made of particles, and we're going to hang it over the moon, pretend you're on the moon here. And let's say that that block has 10 particles in it. Now we'll come back to that idea in a minute, but it's made of particles, protons, neutrons, electrons, and again we'll come back to that. So we hang it from our spring scale while we're on the moon, and that will actually cause the spring to pull down a little bit, and we could read a number on our spring scale. Okay, so let's say it pulls it down a little bit, and the number we read, I'm just going to make up a number, let's say it's 10 newtons. What are we measuring here? We are measuring how attracted this item is to the moon. That is the measurement. Okay, and that is a measurement of weight. Now let's take that same exact item and let's fly it over to the earth. So I'm going to redraw it over here. How many particles would it have in it? Yep, it would still have 10. I think I have 10 there. But let's hang it from our spring scale. And it turns out it would pull much harder on the spring scale. There is more attraction to the earth than there is the moon, and so that spring scale might read 60 newtons now. So the weight increased from the moon to the earth, and that is because the earth has more mass, so it pulls harder on the other object than the moon does. Now let's go back and look at mass, which I haven't quite talked about yet. So let's look at mass of our objects. Turns out mass is a measurement of the number of particles in an object. And if you took chemistry before this, you know that really you're mostly looking at protons and neutrons. So these little dots I drew in here or here represent really particles. And you'll notice when we're over the moon here, I have 10 particles. Now we can't count particles very easily, so we came up with a different unit to count particles, and we called it a gram. So let's just pretend that this is 10 grams. Okay, and if we flew it over to the Earth, did it gain or lose any particles? No. So in fact, it still has the exact same mass of 10 grams. So you can see the mass here didn't change. However, the weight did change. The attraction between the two objects changed, but the mass of the object here stays the same. So let's recap here just a little bit. Mass is the amount of stuff in an object, and the mass does not change for this box no matter where in the universe I am. Okay? However, the weight or the gravitational attraction of the box to each planet changed. Let me see if I can give you another analogy to help you understand how mass would stay the same. A simple balance in science measures mass, and really it's just a teeter-totter. So if I took this box and I put it on a teeter-totter, and let's say it had 10 particles in it, it would take 10 particles to balance it on the other side. And if I did the exact same experiment with the exact same box on the Earth, and I had 10 particles on this side, it would take 10 particles to balance it on that side. And so you can see a teeter-totter is a simple balance, and it would actually work in either place just fine. Okay. So here is a screenshot of basically a summary in sort of word form of the difference between weight and mass. And you can pause and copy that down if you need to in your journal to take some notes on. But mass is basically how much stuff is an object. Specifically, that's protons and neutrons. We use a balance to measure it. The unit we use in science is a gram. And it doesn't change depending on where you are in the location because you always have the same amount of stuff in the object. Weight, on the other hand, is an attraction between two objects. It is affected by mass. The more mass something has, the more gravitational pull it has. It's also affected by distance away from an object. So the further apart two objects are, the less pull you will feel and the less weight you will feel. Spring scale is how we typically measure weight in a science class. The unit we would use is called a Newton, and it does change depending on your location.